I am Dr. Shailesh Pawar, Assistant Professor, Department of Physics, DBF Dayanand College of Arts and Science, Solapur. Today we are going to discuss Hygiene's eyepiece from the BSc first year Physics paper to Optics and Laser. The name of the chapter is Optical Instruments. An optical instrument is used for the two purposes. The number one purpose is to process light waves to enhance an image for viewing, and the second purpose is to analyze light waves or photons to determine characteristic properties of incident light. Here on the screen you can see different optical instruments such as the spectrometer, microscope, telescope, optical bench, binoculars, etc. In all these optical instruments, the eyepiece is one of the important part. An optical instrument is required to produce a magnified image free from aberrations and bright image covering a wide field of view. The single eye lens cannot produce such an image. So, the extra lens called as field lens along with eye lens is used in the eyepiece. So, the eyepiece, or sometimes it is called as ocular, consists of the two lenses. One lens is called as field lens and another lens is called as eye lens. There are two types of eyepieces. One is positive eyepiece and another is negative eyepiece. Today we are going to discuss one of the negative type of eyepiece called as the Hygiene's eyepiece. The diagram, you can see the ray diagram of the Hygiene's eyepiece. Hygiene's eyepiece consists of two plano-convex lenses having focal length in the ratio 3:1. Plano-convex lenses means one face of the lens is plane and another face is convex surface. That lens is called as the plano-convex lens. On the screen you can see the two lenses. One is the eye lens and another is the field lens. Eye lens focal length suppose is f, then the focal length of field lens would be 3f. The distance between them, the distance between the two lenses is equal to the difference of their focal length. Here the focal lengths are 3f and f. So 3f minus f is equal to 2f. This is the distance between the two lenses. You can see on the figure that is 2f. 2f is the distance between the two lenses. In the diagram you can observe I1, it is the image of distant object formed by the objective in the absence of field lens. Note here the objective lens is not shown in the figure. The parallel rays from the objective, they incident on the field lens and they form the image at the I1 dash. In the absence of objective lens, the I1, at the I1, the image of distant object is formed. The image formed is at the focus of the eye lens, hence image is seen at infinity. It is a negative type of eyepiece in which both chromatic and spherical aberrations are minimized. Now we can check the conditions for achromatism and the minimum spherical aberration. The first is the condition for achromatic combination. The condition is that the distance d between the lenses should be equal to the mean of their focal length. Here the distance between the two lenses is 3f minus f is equal to 2f, and the mean of the focal length, so the one focal length is 3f and another focal length is f. So 3f plus f divided by 2, we get it as 4f divided by 2 equal to 2f. So here we can say that the distance between the two lenses is equal to the mean of focal lengths. So we can say the condition for achromatic combination is satisfied. Now the second condition is the condition for minimum spherical aberration. The condition is that the two plano-convex lenses must be facing towards incident light, and the distance between them should be equal to the difference in their focal lengths. Here the plano-convex lenses are facing towards the incident light, as we can observe in the figure here, that is both the lenses are facing towards the object. Object is supposed kept at the left and image we are getting on the right side. So here the two plano-convex lenses are facing towards the incident light, and the distance between them is equal to 3f minus f is equal to 2f. Hence the condition for minimum spherical aberration is also satisfied. Now we can find the equivalent focal length capital F. We know small f and 3f, these are the focal lengths of the eye lens and field lens respectively. But when we take the combination of the two lenses, their focal length we have to find, the focal length of combination. The focal length of combination for the eyepiece is 1 upon capital F equal to 1 upon small f plus 1 upon 3f minus d upon f into 3f, where this d is nothing but the distance between the two lenses. If you solve this, 1 upon f plus 1 upon 3f minus 2f, the distance d is equal to 2f, so that is substituted here, 2f divided by 3f square. So 3f square, if you take the LCM and if you add the numerator, so it will be 3f plus f minus 2f divided by 3f square, that will give us 2 upon 3f. By taking the inverse of this, we get the capital F value as capital F equal to 3f divided by 2. If you observe again the ray diagram, here we have to check whether we can put or here the cross wires or not. Here we say that the cross wires cannot be used in this eyepiece. That is why this eyepiece is called as the negative type of eyepiece. We have to check why we cannot put or place the cross wires here. Because if the cross wires are to be used, they must be placed at I dash, I1 dash, between the field lens and eye lens. The cross wires will be viewed through eye lens only, and the distant object will be viewed through both lenses. Therefore, magnification of the cross wire and object will not be in the same proportion. Hence, the relative lengths of the images will also not in the same proportion. Huygens eyepiece is known as negative eyepiece because the real inverted image formed by the objective is behind the field lens, and it acts as the virtual object for the eye lens. Therefore, this eyepiece cannot be used to examine directly an object or real image formed by the objective. So here is the summary what we discussed today, that is Huygens eyepiece. Huygens eyepiece consists of two plano-convex lenses having focal length in the ratio 3:1. The condition for achromatic combination is satisfied. The condition for minimum spherical aberration is also satisfied. The cross wires we cannot used here. equivalent focal length is equal to 3f divided